Today we're going to talk about how to solve an exponential equation with logarithms. And in order to solve an exponential equation with logarithms, we frequently need to use what's written here that I'm actually going to highlight because I think it's important enough to. What I oftentimes call the power property of logarithms. And what the power property of logarithms says is if we write log base b of a to the x, what happens is we can take the exponent of x and rewrite it as a coefficient, as a number out in front of the logarithm. And we're going to use that extensively today, so I'm not going to linger on more about it. We need to use it. So when we look at this first part here, simplify each of the following logarithmic expressions using the logarithm law stated above. Again, all that means is we take the exponent here, we're going to take the exponent, and we're going to rewrite it as a coefficient. And I frequently make that symbolism there with circling and drawing the arrow. 2 log of x. By the way, what's the base on that log without one written? It's 10. You can't get that thumb up there, but it's 10. Letter B. The power property says we take the exponent in this problem and we rewrite it as a coefficient on the logarithm. This becomes 9 log base 3 of x. And over here on part C, same thing. The exponent becomes the coefficient, and it becomes x log base 2 of 100. The exponent becomes the coefficient of the logarithm. And we're going to use that so much in the notes today that I really think that you'll be fine with this. In fact, these steps here, as we now apply this rule to solving exponential equations, these steps are good steps. The first step, when we want to solve this equation, 4 to the x equals 8. And by the way, there's no way that 4 can be multiplied by itself to get 8. I mean, yes, it's true, 4 times 2 is 8, but in this equation, this says 4 to what power? So it's going to be 4 times itself how many times? Gives us 8. Well, what we can do, because we can't actually solve that, is we can, first of all, put a common log in front of both those values. So it's going to be log of 4 to the x equals log of 8. Second step, use the logarithm property that we just talked about. And that logarithm property says that we're going to take this exponent and we're going to rewrite it as a coefficient. So that's going to be step 2. So it's going to be x, and then we have log of 4, and we have log of 8. Third step. Isolate the variable x by dividing both sides by log of 4. It's x multiplied by log 4. So our inverse operation is going to be to divide by log 4. And now to get that result, we're going to type this in a calculator. So we go to the calculator. And we're going to type in log, remember it's the 4th button from the bottom to the left of your calculator, log of 8, close the parentheses, divided by log of 4, log 4, close the parentheses. I like to use my fraction button on these, but you don't have to. And some of us in this room can't, which is why I show it this way. And press enter, and we get our value there of 1.5. Now it says down here at the bottom, it says, no, do not round into the very end. Well, in this one, we don't have to worry about that, but we are going to get into problems where we do need to round. And we've talked about that in our past notes, so hopefully we can continue to apply that. I am going to be referring back to these steps over and over and over today, just so you can be aware. The beauty of this logarithm law is that it removes the variable from the exponent. And that's the thing. That's the hard part of this problem, is the variables in the exponent. But this law, in combination with the logarithm of base 10, which is called our common logarithm, allows us to solve almost any exponential equation, especially if we have a calculator. If we don't have a calculator, we're not going to be able to find the answers to these problems. But as we take a look at part A, very, very similar to what we just did on our first example there. And our first step says take the common log of both sides. This is going to be log of 5 to the x equals log of 18. Second step, rewrite this so that that exponent is going to be a coefficient using what I sometimes call the power property, which means that we're going to take this x and we're going to write it as coefficient. So it's going to be x log 5 equals log 18. Third step, isolate the variable x, in this case now, by dividing both sides by log 5. We're going to divide this by log 5. We're going to divide this by log 5. And when we do that, we're going to get our result here, but we're going to have to type this in our calculator. So we come over here to our calculator. Log 18, close the parentheses, divided by log of 5, close the parentheses, enter, gives us this big long decimal. As we look a little bit more closely at our directions here, it says round to the nearest thousand. Well, the thousandths is the third decimal place. So we need to look at the fourth spot there, the 8, to determine what to round to. Because 8 is 5 or higher, that 5 right before the 8 is going to round up, and we get 1.796. Now there's another nice thing that we can show here to check our work. And what can happen here, leave this number in your calculator, is we can go back to the original problem. And what we can do is we can type in 5, and it's going to be to the, so there's your caret. And what happens here is you can use this button, second, and the negative button. That should take care of all of you. Wherever the answer, actually I don't know where the answer button is on the Inspires, but I know something that we can do that'll work for you. 5, and then I did second, and the negative button puts the answer. What it's doing is it's taking the 1.795888947, and it's filling it in there without us having to type that whole big long decimal in there. And when we press enter, we better get 18. And sure enough, we do. Now, if you have an Inspire, or even the TI-84s, another thing that you can do is you can type in 5, and then you can go back and you can highlight this decimal place, the 1.795888947. And I got to go back, I'm really sorry, because I forgot to put in the caret here. 5 caret. Then we go back, and we highlight that number there, press enter, and let's try a third time. 5 caret, go back and highlight, enter. Now it takes that value that we got our answer from and puts it into the exponent, 5 to the x, so there's our x value we came up with, and press enter, and that will also give us 18. I made it harder than it needed to be. We'll try it again on that next one. But that's a way for us to check our work. Letter B. 100 equals 4 to the x. Steps are still the same. Take the common log of both sides. It doesn't matter that the exponent part of this problem is on the right. We're going to put log in on both sides. Log of 100 equals log 4 to the x. Step 2. Use our logarithm law, which says that we can take the exponent and we can write it as a coefficient. So we can take this x and we can write it out here in front. And then we still have log of 100 on the left side, and we have log of 4 on the right side. Step 3. Isolate the x by dividing both sides, in this case by log of 4. We're going to divide this side by log of 4. We're going to divide the left by log of 4. And then type it in a calculator. The thing is, if you don't have a calculator, at least on a test or a quiz where your friend might not be able to loan you your calculator, at least do that much so that we know that you know how to solve this. But when we type it in, log of 100, close the parentheses, divided by log of 4, close the parentheses, gives us our value here, and we end up with x equals, well, we're going to look at the 4th decimal space, the 9, to determine where to round. And when we round it, because 9 is 5 or higher, we're going to get 3.322. One more time to check it here. Just hopefully I can do a little bit better job in terms of typing it in. Leave that number in your calculator. So our problem said it's 4 to the x. So it's going to be 4 to the, and second answer, that's going to take this 3.321928095 and put it in for our exponent. Gives us 100, which we want. It should match the other side. Or 4 caret, and then we can go back, and I think I might have done it wrong again. And highlight there, but I don't think it's going to go in the right place. Yep, it didn't go there. 4 caret, and go, what am I doing wrong? Up, there we go, up, enter, and then we should still get 100. I can help you individually if you need that help on your calculators, tomorrow especially. Well, let's flip our page now. And on example number 4, the difference on these examples, part A and part B, is that they're a little bit more complicated. And they're a little bit more complicated because we have 2x for our exponent. Or in part B, we have x divided by 3 for our exponent. But the process is still the same. It's just going to take us one more step to solve. And we're going to start by putting log in for both sides. It's 1.03 to the 2x equals log of 2. Second step, use our logarithmic property, which says that we can take the exponent and make it the coefficient. So it's 2x log of 1.03 equals log of 2. But we're going to isolate the x term in this case. It's 2x times log of 1.03. So we are going to divide by log of 1.03 on both sides. Now, that 2x is still over here on the left. We can type this in, but remember what we said on the front page. Don't round until the very end. So when we type this in, log 2, close the parentheses, divided by log of 1.03. It's going to give us a big long decimal when I type that in. Leave that value in your calculator. And I'm even going to write down a shortened version. I'm not going to round it, 23.449. But approximately, we get 23.449. I'm only writing that down because I want to finish with the math, and then I'll round at the end. I still have the number in the calculator, because now it's 2 times x. We're going to divide both sides by 2. And that's why we need that number in our calculator, because it's there. We're going to divide by 2. And when we do, we get our value here of 11.725 because the 8 after the 4 is 5 or higher. So again, we get 11.725. Don't know why I switched colors. You can check that in your calculator. I'm not going to spend my time on that for now. But you can always check. And that's the nice thing. You should know before you turn in your quiz whether you got the problem right. You should know when you turn in your test whether you got the problem right. Part B, still on problem number 4. Again, the more complicated here is that the exponent is more than just x. In this case, x divided by 3. The process doesn't change. We're going to put the common log in for both sides. And it's 9 to the x over 3 equals log of 13. Second step. We need to use our our power property of logarithms. We're going to take this x over 3 and make it a coefficient. So I'm going to write it like that, x over 3 log of 9 equals log of 13. And deal with the logarithms right now. It's x over 3 multiplied by log 9. So we're going to divide by log 9. And that's what we're going to type into our calculator. The log 9s on the left side cancel out. We're still left with x divided by 3. But we're going to come over here and we're going to type in log 13, close the parentheses, divided by log of 9. And get this big long decimal. which I'm gonna write down a couple of places here just to be able to finish the problem. Don't take that number out of your calculator. So we've got 1.167. Well, over here on the left, we have x divided by 3. Our inverse operation of division is multiply. So we're going to multiply this side by 3. And if we multiply the left side by 3, then we're going to multiply the right side by 3. And the 3's cancel out. We get x equals, well, remember, we still have that 1.167 in the calculator. All we have to type is multiplied by 3. And we get our answer to our problem. And now we'll round it for our final value. Once again, look at this value, the 4th decimal space, the 0 this time. Because 0 is less than 5, it's 43210, we're going to leave the number alone, and it's going to be 3.502. So hopefully by now, because we've done a lot of examples, you're kind of getting the hang of things. But the problems can even get a little bit more complicated, as we see on example number 5. Solve each of the following exponential expressions. Use your knowledge of how to solve equations to help you. The strategies used here are really going to help when we start solving exponential models in a few days. And we're still going to round the answers to the nearest thousand. Well, as I was working through the notes, I wrote one word down here that I need to make sure to emphasize. And the strategy used in solving equations is to isolate the variable. We need to get that variable by itself before we can even apply the logarithmic rules. So we have to go back to some of our Algebra 1 techniques. For instance, this problem says minus 3. Well, what's the inverse operation of minus 3? It's going to be add 3. So we're going to add 3 to both sides. We get 4 times 2 to the x equals 17 plus 3, which is 20. And it's not isolated yet. It's 4 times 2 to the x. Well, we're going to divide both sides by 4. And when we divide both sides by 4, now our 2 to the x is isolated. There's one term on the left side. And that looks remarkably familiar to what we did on the front of this paper, which is, now we've got a log, a common log, and for both sides. Does not matter that you have the parentheses here. We don't necessarily need them. The other thing to keep in mind is that we are going to use our power property, which says we can take the exponent and rewrite it as a coefficient. So it's going to be x of log of 2 equals log of 5. So we did a lot of work up front, but then, like I said, it's remarkably similar to what we did on front. Because now it's just x for our exponent, which became that coefficient. We're going to divide this side by log 2, and this side by log 2. And that's going to give us our value of x, which we're going to type into our calculator. And it is log 5 divided by log, gotta hit the divide, divided by log 2. And here's our value. We need to round to the nearest thousand. So we're looking at the fourth position here. And our fourth position is the 9. So we are going to round that 1 up to 2.322. Going to skip letter B and go to letter C. They have the same process in both. We need to isolate the variable. And the variable happens to be the exponent. So what's going to happen on this particular problem is we're going to divide both sides by 17. When we do, we get 5 to the x equals 4 divided by 17. When we come over here to our calculator and we type in 4 divided by 17, we get this big long decimal. And I don't know about you, but I don't want to write down a big long decimal every single time I go to solve. So I'm going to leave this problem as just 4 divided by 17. But we've isolated. And once we isolate, what we need to put in here is, we're going to put in the logarithm, common log. There's going to be a log over here, and a log over here. And it's log of 5 to the x equals log of 417. Still following the steps from the front page. Using the power property, which says that we take that value of x and we write it as a coefficient. And for some of you, I'm starting to sound like a broken record. I've said it so often. But we get x. Log 5 equals log of 4/17. But we're trying to figure out what x equals. So our third step says that it's x multiplied by log of 5. So our inverse operation is going to be to divide by log of 5. We're going to divide by log of 5. So on the left, then, we're left with x. And then we're going to type this in from the right. You do not have to have a fraction button to type this in. I use it because I have it, but you don't have to have it. So when we type this in, it's log of 4 divided by 17. There's the 4/17. Close the parentheses. Divided by log of 5. Close the parentheses. And then we can round at the end. There's our decimal value. So when we look at this, we're going to look at the 0 in this case, which means we're going to end up with negative 0.899. The 0 is 4 or less. We keep that number the same. The key for solving more complicated logarithms is that we isolate the variable. The last type of problem here that we need to deal with is, what do we do when we have an e in the problem? And it says, what if we were asked to solve an exponential equation with the number e? Let's give those a shot. Recall you might want to use the natural logarithm here. And if you did do problems 10 and 11 on the previous practice, this is where it comes into play. Because what can happen here is we can write this as log of e to the x equals log of 14. But because there's an e in this problem, it's a little bit easier to write down the natural log. of e to the x and the natural log of 14. Can you solve it with the first step? Yes. I'm going to go for the second step here just for a little difference and to get you acclimated to where is that button on the calculator. But regardless of whether we use log, our common log, or we use ln, our natural log, the power property still applies. We're going to take this x and we're going to write it out in front. So it's going to be x natural log of e equals natural log of 14. And then it's x times the natural log. So our inverse operation is going to be to divide by the natural log. So we type it in. Natural log is going to be the third button up from the bottom instead of the fourth button that we've been using for the whole period. Natural log of, I already forgot the number, 14. 14. Close the parentheses. Divided by the natural log and the e. The e button that I'm using here is that second and the division button. If you happen to use second ln, you have to put the exponent of 1 in there. So if an exponent pops up, put a 1 in there. But when we divide, we get this value of 2.639, and it's 0.39 because we ended up with that 0 there at the end. So it's 2.639. 0 means that we're going to leave that 9 the same. Finishing very quickly with letter B on this one. And one last time, I just want to stress to you, isolate. Isolate as much as you can before you put in common log or natural log. It doesn't matter so much what the isolating does. Subtract 1 from both sides. We get 2 e to the x equals 26. Well, it's 2 times e to the x. So we're going to divide both sides by 2. And we get e to the x equals 13. Now that we've isolated, again, because there's an e in this problem, I recommend that you use ln, but some people are always going to use log because it's the first one that we taught. But regardless, we should get the same value as long as we use the appropriate steps. We put the ln in here, and we're going to use our power property to put the x. So it's x ln of e equals ln of 13. When we divide both sides by ln of e, we'll get our value of x equals ln of 13 divided by ln of e. Don't forget to close your parentheses. That's going to make a difference if you don't close that parentheses on the 13. It gives us our decimal, which we have to round to 2.565. Because we have a 9 there in our fourth position.